Hey everyone, welcome to my channel Week. Today we will going to discuss about the oxygen dissociation curve. There is a very important curve for the binding and the dissociation of oxygen in the hemoglobin. So this curve is very important, and before discussing the curve, we have to know what is the concentration and how the oxygen is dissociated and bind in the body. So coming to the diagram, here it is shown the diagram showing that here is the presence of the lungs and here is the presence of the tissues. While that is the hemoglobin that is carrying the oxygen, there is the oxyhemoglobin and the carb amino hemoglobin that carrying the carbon dioxide or the deoxyhemoglobin. So from the lungs, what happens when the oxygen, that is clear oxygen, bind with the lungs with the hemoglobin, it combines with the hemoglobin and the hemoglobin carry 4 molecules of the oxygen with it and going to diffuse this oxygen in the tissues. What happens that this oxygen is released from the hemoglobin and diffuses in the tissues, and the carbon dioxide, that is a metabolic waste from the tissues, released and combined with the hemoglobin, that is a carrier of oxygen. When this carbon dioxide combines with the hemoglobin, it forms the carb amino hemoglobin, and this carb amino hemoglobin is carried again towards the lungs for the release of carbon dioxide from the hemoglobin, and then towards the upper respiratory tract, and then towards the exhalation through the nasal cavity. So here, that's why how the exchange between the oxygen and the carbon dioxide is taking place in our body, and between the lungs and the tissues, how the oxyhemoglobin is going to diffuse the oxygen, and deoxyhemoglobin, the carbon amino hemoglobin, is going to excrete out the carbon dioxide. Now here you can see I have drawn a diagram about the oxygen dissociation curve. So what is the oxygen dissociation curve? It is a curve when there is plotting of the y-axis having the percentage of saturation of oxygen, and on the x-axis we plot partial pressure of the oxygen. There is a PO2. So what is the curve showing? That the oxygen is dissociating at a rate in the hemoglobin or the myoglobin. What happens when the myoglobin carrying the one molecule of oxygen is going to dissociate in the lungs and is going to dissociate in the tissues? Myoglobin having the one oxygen of hemoglobin, it is very simple for myoglobin to diffuse, and it is very simple to bind the hemoglobin oxygen. That's why this myoglobin is showing the hyperbolic curve. This curve is going to increase ultimately, and then at the maximum state it going to diffuse the oxygen in the lungs. Also, one more thing here, you can see that the partial pressure of the myoglobin in the partial pressure of oxygen in the myoglobin is very much less. It's about 1. That is, the myoglobin easily get the partial pressure of oxygen, get easily saturated with oxygen, and it can easily release the oxygen at the high level. That's why this myoglobin is showing the hyperbolic curve, and it can carry about 1 molecule of the oxygen per time. But what is the condition of the hemoglobin? When the hemoglobin is combined with the oxygen in the lungs and it is diffused in the tissues, what happens? Because this, you can see that the partial pressure of the oxygen when combined with the hemoglobin is increased than the myoglobin. It's about 26, and it is going to combine with the higher partial pressure of oxygen in the tissues. It is going to release that oxygen, and it can combine, when it combines with the higher partial pressure of oxygen, it goes to increase with that partial pressure of oxygen, and then in the lungs it is going to diffuse that oxygen. So here you can see this is showing the sigmoid curve, which is showing that there is a decrease in the saturation of oxygen in the tissue level, but there is an increase in the oxygen partial pressure in the lungs. Why? Because when we have discussed that in the lungs there is an oxygenation of the hemoglobin, and the oxygen is increased, and then it combined with the oxyhemoglobin, and the oxyhemoglobin carried to the tissues where it dissociates the oxygen. That's why there is a decrease in the saturation of oxygen. So by this way you can see this is showing a sigmoid shape curve. This sigmoid shape curve of hemoglobin is very important for the releasing and the binding of the oxygen with the hemoglobin. That's why it is also causing the increase in the affinity of oxygen. When one oxygen combines with the hemoglobin, it causes the increased affinity to combine with the other molecules of oxygen. In this diagram, you all can see that there is an increasing affinity of oxygen. When one molecule of oxygen combines with the hemoglobin, the other molecule combine easily with the hemoglobin, and at last 4 molecules of the oxygen combine with the hemoglobin, and there is a very much increase in the affinity for the combining with the oxygen. Now coming to the factors or the allosteric factors that affect the oxygen dissociation curve and how they are going to increase and decrease the oxygen dissociation curve. Discuss in next part.